Okay, let's take a look at chapter 8, problem number 9. So this is a population proportion problem. So we're finding an interval estimate given a proportion. So this says fewer young people are driving in 1995. 63.9% of people under 20 years old who were eligible had driver's license. Bloomberg reported that the percentage had dropped to 41.7% in 2016. Suppose that these results are based on a random sample of 1,200 people under 20 years old who were eligible to have a driver's license in 1995 and again in 2016. So then they want us to find the confidence, or at 95% confidence, they want the margin of error and the interval estimate for people who had a driver's license in 95 and then again in 2016. All right, so let me open up an Excel worksheet here. There's my Excel worksheet. I'm going to go ahead and resize this so we can look at both of them at the same time. And all right, so let's start with what we know. So for 1995, we know that we have a proportion of 0.639. You have to be careful because they give us all these numbers like 20 years old that don't mean anything to us. We know our sample size was 1,200. And we know that our confidence level is 0.95. Whoops. And if we have confidence of 0.95, then we're going to have an alpha of 1 minus the confidence level. And since we're going to need it, I'll just go ahead and do it now. The z-score of our alpha divided by 2, which again, we always want a positive value for this. So I just do absolute value of norm dot s dot inv of my alpha divided by 2. All right, so that's what we know going into this. So our formula to do a margin of error is it's the z-score of alpha divided by 2 times the square root of the proportion times 1 minus the proportion over n. Okay, so it's just this. Oh, whoops. So it equals the z-score of alpha divided by 2 times, whoops, I'm making a lot of errors. There you go, times the square root of our proportion times 1 minus our proportion divided by n. I think I put an extra parenthesis I didn't need there, but that's all right. The big thing is making sure you get the square root of all of those things, so that of the proportion minus or times 1 minus proportion over n, it's the square root of all of that together. So there's our margin of error, 0.0272. We can check it if we want to make sure we're on the right track. We are. So then our interval estimate is really, we're going to just have a lower end of the interval and an upper end of the interval. And it's really just our proportion minus the margin of error. That's the lower end of our interval. And our proportion plus the margin of error will be the upper end of our interval. So we'll say 0.6118 and 0.6662. So in essence, what we're saying is we'll be given a sample proportion of 0.639 and a sample of 1,200 and a confidence of 0.95. Okay, we're 95% confident that our interval is going to be between 0.6118 and 0.6662. In other words, we don't know if 0.639 is exactly right, but we're 95% confident that the true proportion of people who are driving at under 20 years old is somewhere between 61.818% and 66.62%. Okay, so now that we have our little calculator made, I'm just gonna, actually, I guess we could copy and paste. And we'll do this for 2016. Now our proportion is 0.417. And everything else is the same. The N is the same confidence, and since our confidence is the same, that means our alpha and our Z of alpha 2 is going to be the same, but it recalculates our margin of error and our lower and upper bounds for us. So let's make sure that's right. All right, so our margin of error is 0.0279. Which makes our interval estimate 0.3891 to 0.4449. We'll check our work. We're in good shape. So then it wants to know, is the margin of error the same as in both parts? And you're like, doy, no, it's higher in part B here. So no. And this says why or why not. And we're going to say, so we know the margin of error is larger in part B. So that narrows our answer down to either this one or this one. And it's because the sample proportion is closer to 0.5 in B than it is in part A, or vice versa. So if we look at our proportion of 0.417, which is what it was in part B, that is only 0.83 away from 0.5, and 0.639 is 0.13. So we're going to say our sample proportion is closer to 0.5 in part B than part A. So we're going to choose that one. We'll check our work and we're good. So hopefully that was helpful to you. And if not, of course, you can always reach out for more help.